on. Look at how it's the bottom.
Oh my gosh, Brenda.
Is it recording right now?
No.
We're all zooming.
No, yeah, it is recording.
Oh, what's up, bro?
If he even wants he needs to. There's quick review 2, the answer. Ooh, that's a nice answer.
Wait, hold on.
This was like from Friday. You're supposed to do quick review 1 and 2.
Wait, what was it? 5.5?
5.5, quick review 1 and 2.
Yeah, I didn't get that.
I cannot believe I got that. Wow.
No, I did not get that.
It's just a
X
derivative.
sine of X.
I got
X sine of X,
sine
yeah.
minus X.
That whole
I
thing?
didn't get
Nope,
that.
didn't get that.
Did you get that? Low D high minus high D high.
Yeah,
I got that, yeah.
Where, well, then it's just simplifying it. It's just distributive property, x times 1 is x times sine of x is x sine of x. 1 times 1, right? Sine of x.
Oh, I did sine of X squared. But that's wrong.
Oh, yeah, and then distribute the negative. Yeah, so, I don't know. There, which ones did I give you for 5.5 the first night? Because I think I
2,
did.
3, 11,
1,000,
14.
Holy moly, that's not even close to what I have.
You gave us 14.
Well, the last time you gave us 1, 2, quick review, and then 1, 2, 5.
1, 2, 5? Yeah, that's what I got here. There's 2. You should get 4.92.
I've got 4.3.
Wait, what do you
What do they gave you this thing, and they told you at a equals -4 to do the linearization, which basically means 5
It gave you 4.1, because I stopped right after I found the tangent.
No, it said to do a plus 0.1, so technically you do 3.9. It's -4 plus 0.1 is -3.9.
Wait, but if you plug in -4 to the derivative, which is up 1, right? The x over.
Negative 4.
Your L of x, your tangent line should be negative, it should be this, right? -4/5 for your slope. Y minus 5.
Yeah, but how do you get 4/5 if you plug in -4? -4 squared is 16 plus 9 is not 5.
You get -4 over 5.
You get the square root of 25?
Yeah.
Okay.
Wait, I'm confused on what you're supposed to plug. How you're supposed to get the other number?
Over here,
Yeah, that.
once you have your tangent line, you just plug in -3.9 for it,
Why?
because that's
Because
what it
that's
told you to do.
one.
Oh.
It's 0.1 more. Did you do 4.1?
I didn't do nothing because I didn't know how to do it.
Okay, yeah. You're supposed to just plug in, yeah, that's stupid. Whatever. What was the next?
Wait, don't.
3?
Yeah.
Okay, I'm number 3. It's right there. Tangent line, I don't know. Let's see. Is that it?
No.
There's the derivative. There's the derivative.
Yeah, so once you get the derivative, you plug in 1,
Plug
right?
in 1, so the slope is 0.
0.
So your tangent line is y equals 2.
Because if you plug in 1, you get
I didn't do this
2.
right.
What the? Why don't you get that right?
The original equation.
Oh, because you don't
is
have an
plus one
x,
over
right?
X.
Oh my gosh, I'm such an idiot.
Number 3?
Yeah.
Oh, it's this.
Did I do it wrong?
No.
I think you're wrong.
So you have your slope, so
Yeah,
it'd be
it is.
0 times x minus 1, right? And then you
Oh, yeah, I
get
did.
0 for x. So you have add
What did I
1.
do?
0 times 1 is 0.
Is this wrong?
No,
Yes.
no.
I think I'm wrong.
Can you write the equation, the
Let's just do it over.
y minus 2?
There's the problem. It says a equals 1.
You plug that back and you get 2.
Point 2. So your point 1. Find the tangent line to this through the point 1, 2, right? So the derivative of that, 1 plus, that's x to the -1, so it'd be negative x to the -2.
Which is negative x, no, you bring it down 1 over negative x squared.
So it's 1 minus 1 over x squared. There's your derivative. So then you get your slope, plug in 1, so y prime of 1 is 0. Right? So your slope is 0, so your tangent line then,
Y minus
y
2.
minus 2 equals 0 times x minus, well, yeah, that's just 0, so y equals 2.
Okay.
Yeah, a horizontal line goes through y equals 2. So y equals 2. So no matter what you plug in, you're going to get 2. So when it says to plug in 1.1 or, yeah, 1.1, you're still going to get 2. Let's do the square root ones. I think those make more sense. What was the next number?
1, oh, 11,
11.
sorry.
11? I'm going to do 11. I'll just do 11 right
I think these are easier
now. So the square root of
What exactly is
101.
the point of these? That makes me think.
to find the, what?
Because I can do them, I exactly.
I do have an answer, I don't know what type it is though. Wait, what is it?
It's like to find the square root without using a calculator, but you use the linearization way.
So just find the actual answer to it?
Well, first you have to write a function.
100 plus square root.
Just pick the closest square root that you actually know, and then put plus x. So there's your function, so then you find the tangent line to that function.
Wait, can you round it up? Yeah, you can, huh?
What?
Because you rounded down right there.
Oh, did you go up to 121?
No, but in the next question I was confused if I could round up.
Oh,
or-
because it was 80.
Oh, yeah, you can go up, you can go 81.
Oh, I didn't know that.
But then you would do 81 minus.
What'd you do?
Oh, I did that.
At first I did 64 and I'm just like, you know what, I'm just going to do 81.
I did 64.
Yeah, I did
Yeah, like for
64.
this one, you could do 121 minus x,
And you still going to
and
get
use
that too?
x equal 20, but you're just not going to be as accurate,
Oh.
That'd be as close as possible.
because you want to be as close as possible to that, so that when you do your, because your line and your curve are they're gonna get farther away from each other the further you go out. So you can do it, but you're just most accurate is right here. So then derivative would be, let's see, that's half power, so 1/2 times inside. There is no outside. -1/2.
1 over 2, the square root of 100 plus x.
Just doing the derivative of that. So it's
1 over
1 over 2
2
times the square root of 100 plus x. And we want to do it when x is
It's 1.
So when x is 1, what's our
Y is
slope?
10. Oh.
Oh, no. No.
Your slope is, you want to plug in 0.
You want to plug in 0. Why do you want to plug in 0?
You want to get a square root of 100.
Yeah. We'll do it at the point 0, 10. Yeah.
For these type of problems. That'll give you a point. Just because if you look at 100 and you have to add x, you know the square root of 100, but you don't know the square root of
So if I plug in 0, that's
120.
1/20th.
something. Yeah.
So my slope at that point is 1/20th. So my tangent line, that's L of x, is, whoops, I don't know, that's y equals m, supposed to be 4. I could just go y minus 10 equals
120.
1/20th, x minus 0, or just x
Add 10.
at 10. So L of x equals 1/20th x plus 10.
So 10 and 1.
Plug in 1.
Yeah, so if you plug in 1 for x to get the square root of 101, right? You get 10 and 1/20th.
That would be like dx, the difference for the error. Like in the,
No, the error,
well, like
that's,
in the problems you gave us, how
He plugged
dx
in
would be
1.
like the difference from 10
I
to
mean 0.
10.05, you put in 0.05,
Oh, so
right?
I put 0.
That's kind of what, the similar idea, you're plugging in 1 because 1's the difference,
no, you're plugging in 1 because you want to get the square root of 101.
which is the difference between 100 and 101.
Okay.
Same concept.
After 11 was, oh, I did 14 different. Did you get 8.9? Oh, I did.
Yeah, I did.
Wait, which one is that one? 14?
Yeah. Looks like I did a little different last time. I just used square root of x instead of the square root of 81 minus x.
I just equal 8, equal to 8. What the heck?
Yeah, I did it different. You can do it different.
Can you do it the way you taught us?
do square root of x, did the derivative, plugged in 81 for x, still slopes 18.
Because it was closest to 80.
Yeah. Huh, that worked. Want to see it your way?
Yes.
So you want square root of 80, so you probably did
Square root of 81 minus x.
square root of 81 minus x,
Which is 1 over,
0.09.
So you do it,
1 over 2 square root
the
of,
y is what,
So you did 1/2.
yes, square root of 81 minus x.
isn't it negative 1/2 because you have to do the inside and
Ooh, yeah. Good job, Brennan. Derivative of the inside would be -1. Right? That'd be what? That'd be 81 minus x to the 1/2. Derivative of the outside times the derivative of the inside. So yeah, it's -1. So there's your derivative. Plug in 0 for x. So it's -1/19. 18.
That's why.
1 minus 0 is square root of 9. 9 times 2 is, right? So you y minus 9 equals -1/18 times x. So your son of x is -1/18 plus 9. Oops, x plus 9.
How did I get the same answer as you then?
why do you write your 8 for all the time?
I don't know.
That's weird. Like people usually do it one way or the other.
Nope, I'm crazy like that. So then when you plug in, you'd plug in, what would you plug in for x?
Negative 1. Oh, what?
Negative 1. That's what x
No,
is.
'cause
No.
the negative one would
You plugged just
80.
1.
1. Yeah.
Well, that's how I got the same answer. I plugged in -1.
Plug in 1. So you should get 8 and 17/18,
Which is 8.94.
which is
Like
8.9.
two different 8s right there.
That's funny.
¿Cómo se llama algo que no should be that
Is next the differential one? Is that all
Yes, number 6.
They do, Betty.
Should be both ways though.
way? No, 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 voy a porque se me olvida. When I'm there, se me olvida.
I can't even.
There's 6.
Yeah, can you do that?
I don't even know where to
Actually-
start.
Yeah.
Wait, which one?
Number 6. Number 6 is just
Either right.
tangent line
I
again.
got confused.
6 is just like, it's not the differential stuff yet. 6 is just, ooh, inverse cosine. That's fine.
-1 over square root of 1 minus x squared.
At a equals 0, so my point 0. If you plug in 0 for x, what's the inverse cosine of 0?
0.
0.
1.5.
Pi over 2?
It is pi over 2.
Oh, no way. Don't ask me.
Eight,
I was
that's
just putting out a stupid
1.57.
number.
No, just kidding. I don't know.
I think they need to do unit circle review.
Yeah, we do.
Heck yeah.
And then the derivative, you remember the derivative of the inverse cosine?
Yeah, -1 over the square root of 1
-1 over
minus x
square root
squared.
of 1 minus x squared.
I had to look that up.
Yeah, me too.
That's
I
actually-
had to look it up.
You had to look it up?
But I knew it after I wrote it down.
So you plug in 0 for x and you get -1. So your slope's -1.
Okay, that's what.
So you get y minus pi over 2 equals -1 x minus 0.
Equals.
So basically you got -x plus pi over 2.
I didn't know where to put that in a tangent line. I stopped that once I got the slope.
So then it asks, you know, for 0.1 bigger,
Why is it
because they're asking for the linearization.
That is 1.57. Sorry.
1.47.
Huh?
What is
Pi,
it?
no, pi over 2, it is 1.57.
Oh, yeah, but minus 0.1. Because you gotta plug in 0.1.
Yeah, but I was just
When-
talking
when
about
you were
what,
doing the point,
what square root, I mean, what pi over 2 was.
Let's get to the, what? I like how it's a no calculator problem and then you get that. You're like, okay.
Did it tell us to plug in 0.1?
Yeah, that's the part B where it's like, how accurate is the approximation L of A plus 0.1, blah, 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 blah. Whatever. I don't remember what I asked. For our quiz, I'll make sure. I don't even know if we're gonna have a quiz in this section. We might just go straight for the chapter 5 test.
No.
Yeah, I don't think we should have any tests anymore at all.
So I need my grade to go up.
Mine's
After
perfect.
6 was 14, but we already did that one, so then 15. There's 15 and 16.
Why did I get 15?
Wait, 15 is 0.4.
Wait, how did you did that wrong?
I did it wrong?
3 times 4 minus 3, oh, 12 minus 3, never mind. My math was wrong in my head.
Yeah, I didn't do it right.
Oh, I know
That's
what
the only one
I
I
did.
got right.
So when you do the derivative and you get like 3x squared minus 3 dx, you want to do all that together before you multiply it by 0.05.
One, negative 1.
Because I multiplied the 3 by the 0.05 and then multiplied it by the 9.
Next one I got negative 0.13.
Shouldn't matter. No, it'd be 12 times 0.05 minus 3 times 0.05.
Oh, it's multiplication, I subtracted. Yeah, because I did, never mind.
I plugged them in wrong.
Me too.
Put them in wrong. You get it though, you just do the derivative and then plug in the stuff that they gave you. And
Yeah, I think those are easier.
Solve for what you don't know. Were you doing the dy dx the whole time? Like derivative, just dy equals 3x squared?
Nope, I do the derivative and then put
And
dx
then
at the end.
multiply by dx.
I don't even multiply, I just add it.
Well, I just didn't factor like dx. I didn't factor the dx out. So then I just plugged everything.
That's okay. You should still get the
No, I
same
didn't.
thing.
I did it.
Because if you have that, and then you plug stuff in, you would have 3 times 2 squared times
Oh.
0.05
Squared?
minus 3 times 0.05.
Yeah,
So
I
you're
put
telling
cubes.
us it's not necessary for you to factor out dx?
No, not on this problem.
Let me see.
Because all you're doing is just plugging those in. Plugging everything in. You get 0.05. This one was just long because it was quotient rule.
Actually, that's the right answer.
Well, it looks like I didn't do quotient rule, I did product rule. Whatever, you should have put a negative 0.2
How did, oh, you added it up.
Anything, you want to go step by step, slow down. Got it, Pedro? Oh boy, so proud of Pedro. What's next? Is there any more?
Yeah,
31,
31,
31 you said
32.
is like half of the chapter.
31, 32.
Calm yourself.
I hate when I'm
It wasn't
watching the
me.
video.
It was me 2 years ago.
I hate when I'm watching the video and it's like homework, and there's a list that just goes on forever, and I'm like, Sunday afternoon, don't really want to do 20 problems. But I
Should
hate
have done
it.
it Saturday.
Well, usually you don't upload it till Sunday night.
It's because I already had done.
Yeah, well,
Lazy or smart?
lazy.
You know, lazy people are smart because, well, certain people, they get their way around it. Yeah.
Wait, do you consider yourself smart?
Don't encourage it.
You want me to just go over 31, 32, or you want to?
Just do them.
Yeah.
I can just show you the answers. 31, let's see.
I have a question on the derivative.
It says, write a differential formula that estimates a given change of volume or surface area, then use the formula to estimate the change when the independent variable changes from 10 centimeters to 10.05. So whatever our independent variable
We can't
is.
see whatever you're doing.
independent variable is, it's gonna go from 10 centimeters to 10.5 or 0.05. So 31 is volume. It says the change in volume of a sphere. So you're gonna calculate the change in volume of a sphere when the radius changes from A to A plus dr. Did you understand what that meant?
Yes.
So the radius is gonna change.
You explained, I think, in the video.
Yeah.
Oh, I did. See,
You wouldn't know
I
though.
wouldn't know. Radius changes from 10 to 10.05.
Yeah, so your radius is 10, your dx is 0.05. Yeah, we got that.
Yeah, well, your rate R is 10, dr
Oh, dr.
is 10.05.
No, it's 0.05.
Oh, yeah. Ooh, you're right. That would have been a bad mistake.
How
So
would it change
volume
your
equals
answer?
pi r squared, or 4/3 pi r
You should let
squared.
him do it so he can get it.
Volume, not here. 4/3 pi r to the third.
So I have a question on this derivative. If you have two, like, I guess you call them constant, what do you call them? Like the pi and the r? What do they call them?
Well, they're different things. Pi is a constant, r is a variable.
So since they both don't have numbers though, in the video you did r to the third, you did 2r squared, or 3r squared.
Yes.
And then in the end you added it over to the beginning, the 3 to the
Multiplied
4/3. So can you just do it to the beginning, the very
right
beginning?
away, yeah.
Okay.
Yeah, so when you do the derivative of that, obviously the derivative of the left, what's the derivative of the left?
dv.
Just dv equals, we gotta do the derivative of that whole thing. Well, it's just a number times r to the third, so it's just power rule. Just do 3 times this. Well, it's
4.
3 times 4/3.
12/3.
4 pi r
Squared.
squared
D.
dx.
B.
r.
dx. Why can't you just do dy and dx anyway?
You'll, 5.6, you're gonna wanna use whatever letter it is.
Okay, now you plug in 10, you plug in 0.05.
Now you just plug in the crap you know.
10 squared is 100.
So dv equals 4 pi times 10 squared times 0.05.
You get 25.
dr is 0.05. And yeah, you get 20 pi.
Which is 62.83
2.83
centimeters squared cubed.
cubed. That just means if you change, if you've got a sphere, is it what is it, a sphere? Yeah, 4/3. You got a sphere with a radius of 10 and then it goes up to 10.05, that's how much the volume changes by. And then 32 is kind of the same thing, wasn't it?
Yeah.
Oh, it's just surface area. Surface area equals 4 pi r squared. Oh, this, so the radius again changes from 10 to 10.05. So we know r is 10, dr is 10.05.
It's
Oh,
0.05.
did it again. dr is 0.05. So what's the derivative of that?
8 pi r.
I'm sorry.
Plug in 10, plug in 0.05.
Plug in the crap.
You get 12.56 centimeters
4 pi.
cubed.
No, no one's like, need. We're all gonna ditch.
Which is
12.56
centimeters cubed.
squared area.
I got the mixed.
Hey, Penny, let's not show us one day. Yeah? Yeah, yeah. Oh. No lo hace. Who's not going? La que no hay, las como los tres.
I know, but you can come back and tell us.
Keely. Is Nicole? Idea. Yeah, I thought you were.
Well, I went to, I was like, forget any more interviews, just come back and ask.
We're just gonna do some more. Exciting. More differentials. I made a decision about, let's see, we have class every day this week, that's exciting.
No.
Hopefully we'll get our chapter 5 test out of the way before the end of the week.
That'd be nice.
And then, just because of all the Spaniards,
We're gonna be having fun.
5.6 is gonna take a week by itself. So, obviously we're not gonna start it this week. We're gonna take our chapter 5 test. We're gonna start chapter 6 while you're gone, just because it's basics. 5.6 is like the hardest part of things to do in the derivative section. So I don't wanna try to do that while you're gone and have you watch YouTube videos about it, because it won't make sense. 5.6 is like literally I have to just go step by step and we have to work through problems together and be able to talk to each other. So we're gonna start chapter 6, and then when you guys get back, we'll go back to 5.6 and finish it up. Because the beginning of chapter 6 should be kind of easy. It's basics and lots of notes.
So we'll just-
Every single day.
You will have a video every single day.
Can you not do homework on the weekend?
No.
Okay. So we'll have 6 videos.
Yes.
I'm gonna have to watch that on Sunday.
I don't know what you're gonna do.
So we're gonna finish 5. We're gonna finish 5.5 this week then,
Yes.
and take a test when Thursday, Friday.
Probably. Yes. Sure. 5.5 quiz? Just raise the grade? I don't know.
No, I don't think it'll raise it.
Me too.
These
dude.
are the deep ones. I barely got my grade from F and because they had to turn it
This is number 46.
I didn't even know they called the test.
It's about tolerance.
No, I was wondering.
She didn't say anything though.
This one's crazy. This is just one example, and then you're going to try some more.
The first example is crazy.
Yeah. Oh, we only have time for one. So. It says, about how accurately must the interior diameter of a 10-meter-high cylindrical storage tank be measured to calculate the tank's volume to within 1% of its true volume?
So it says 1%. Would that be what we plug in? Is like 0.1. 0.01.
But, what you...
So where do we want to put these numbers? Where to put these?
Yeah, this one's crazy. That's what I'm showing you. So you're trying to figure out how accurately you have to measure it, so that when you calculate the volume, you're within 1% of what it actually is.
So the diameter is 10 meters.
So let's draw a picture. What's a 10-meter high cylindrical storage tank look like?
It says a diameter.
Huh? You know what it's just a cylinder.
Oh, 10 meters.
Talking about me?
Yeah.
There's too many people all talking at the same time.
I said it looks like a wheat storage.
Yeah. So if I don't hear you, it's just,
Because he hates you.
yeah, that's why. Okay, and what do we know about this cylindrical storage tank?
It's 10 meters high.
10 meters high. That's nice. How do you find the volume?
4/3.
Oh, what's a sphere?
Oh.
Yeah, it depends on the circumference.
This is like
2 pi r times height.
The base.
No, that's the surface
height
area. That's
times r to
It's the area of times the
How do you
height.
find area of
The area of the top.
r squared?
Pi r squared
yeah.
times the height. That's the volume.
Are we supposed to
You know the last time we went over these was geometry. Like how are we supposed
Yes.
to remember?
Those are just
I
remember.
know that this.
That's an ugly age.
You actually teach geometry every year. You get review.
No, I didn't teach it last year.
Okay, a year off of what? 10 years? Okay, you haven't been teaching for 10 years.
Okay, calm down. Calm down.
So what do we want to measure the diameter? All right, we're trying to set the problem asks us to how accurately must you measure the diameter to find volume within 1%.
So do you want to put diameter into your volume equation?
Yeah, well, instead of using radius, we're gonna use diameter.
Which would be 2d, right? Well, d times is half of a radius.
Really?
Diameter? Oh no, radius is
Anybody
half
else?
of the diameter.
Yeah.
Yeah, isn't the diameter twice the
So
radius?
1
Yes.
Did you say anybody else?
So instead of R, what am I gonna use?
D,
D.
but you're gonna use
How would I find it in terms of
1/2 D
half a D? Yeah. So or D over 2.
squared.
I can see you looking at me.
So there's our volume.
I can't find one. Where's Carson's
Well, don't we know H?
Yeah, 10.
pen? Oh, I have stored 10.
10.
So solve for D.
So V equals, well, and then let's simplify this. D over 2 squared. What's D over 2 squared?
D squared over 4.
Yeah.
Square over 4.
D squared
D.
What?
I don't know.
times 10. So, we do now, yeah, let's just do, isn't that the same as 1/4 D squared times 10 times pi? I haven't even done the derivative yet, I'm just rewriting.
Huh? We don't know. Sure.
I guess we can leave it like that for now.
Well,
I hate it
Stop.
when I hate it when
Okay, do the derivative now.
totally over. What did I do wrong?
people, like, yeah,
Yeah. Where's the other?
I don't know how. Enthusiastic. Yes.
Oh my God. Really?
Would you put, what would you put for your dx, dh? Or do you not do that? dh, it's not dd,
DD, yeah, it is
It
DD,
is DD?
just because we have the same letter.
that's awkward.
Wait.
I don't know if I remember how to finish this. Smudge stack. Well, okay, let's just move on. Yes, I don't think I'm gonna have you do it. So our dV would be what?
Pi,
Pi. Okay. We can simplify it later.
1/2 d,
Yeah, 2 times the fourth is a half. D,
10,
10,
dd.
DD, so let's rewrite that.
So 1/2 pi d.
You see, I don't get.
Do you,
Go get what?
What's the DD?
Yeah, I don't understand.
it's like dx.
It's like dx,
You
but
find the derivative of that y, you
Oh, but
find the
we're
derivative.
fighting
the derivative of d, so it's dd.
Does it mean
dd.
what?
So can you can't move the 1/2 in front of the pi, can you?
Yeah, we can, it's all multiplication. 10 times a half
That's the furthest thing.
is
Five.
5, so it's 5 pi d
Times dd.
dd. I'm gonna write it different just so that
Which
it's
your
not like
dd would be
ddd.
0.01, right?
5,
Half times 10
10.
times pi is pi pi. So our change in volume will equal 5 times pi times the diameter times the change in diameter.
What if you don't know what your diameter is?
We don't. That's true. But we want to measure the diameter to find the volume within 1%. Okay, so this is where it gets weird. How, when it says we're going to find the volume within 1%, what does that mean?
The
Then it would only be
volume,
1% off.
It would only be 1% off. And how would you calculate that?
By percent error.
Percent, how do you calculate percent error?
You know, like
The
last piece of
lean-
Really? That block over there. It's a metal book and I can't
It's
shoot over.
original minus what you got over original.
Yeah. So
Promise.
original minus what you got, but
That's the
you
only thing I've learned
God.
in chemistry.
over
that's crazy, that's applying.
original.
I know, since
Yeah.
we're mix.
That's percent error, right? So we want our percent error to be within 1%. Well, okay. So original minus what you got, isn't that just the change? Isn't that dv? So all we need to do here then is divide by our original volume. So we know our change in volume. Let's divide by volume to get percent error. And we're going to do that.
So you're gonna get your D.
We're going to do that on both sides. And then we're going to simplify, and then we're going to interpret what we just did. Right? Because we want this to be less.
So since you want your volume, you're gonna divide by your volume.
Since we want the percent error of the
Of
volume, then we're going to divide by volume. We'll dv over the, we'll just leave that. But this, we're going to work on this side. Don't we know what v is?
No.
Yeah, we do.
Oh, pi r.
It's pi r squared,
Yeah,
or it's pi times d over 2 squared times h, which is this, which is this.
So we're gonna plug in pi times 1/4 d
So
squared.
we're going to put all of that in
No,
down
we're
there.
just simplifying.
So we'll have the top.
You're at dv.
5 pi d times dd over volume, which is this whole thing,
Pi 1/4.
which doesn't matter what order you write it. I can just 10/4, or we'll just do pi times 10 times the 4 times d squared. And then we got to simplify that. There should be some crap that cancels out.
A pi.
A pi, a d.
So you left with 4 pi? A pi and d. What is this?
A 5 and a 10 can be
4
1 and
pi.
2.
DD.
I didn't want to laugh, but
Can't you rid of another?
Well, we got this 1/4 in here, and that sucks. Isn't that the same as a 4 on top?
yeah, can't you get another? Oh no, but that's derivative.
That's no, that's dd. That's derivative of d. So 5 divided by
Oh, that's what I
10,
was trying to
4.
say.
This 10 times a fourth is 2.5, right? What's 5 divided by 2.5?
5.
2. So it'd be 2 dd over d. Remember,
Wait, what if
dd
you
is-
did like 1/2 and you put the fourth on the bottom? I don't get how you did that.
Yeah, we're not time. So flip and multiply.
Oh, flip and multiply, okay, so you have 4/2, which is 2, okay. Got it.
So now we got that.
You know what your DD is though?
Do we know our dd?
Yeah.
What is it?
0.1? 0.1?
What's your one? No, that's the.
dd is change in diameter.
Oh, okay, no, we don't. We don't even know the diameter.
Okay, this is where it gets weird. So it,
Already.
it is, it's crazy. It says how accurately must you do it? So you're trying to calculate the acceptable percent error for your diameter
So you plug in the error, which
to
is
get a
0.01.
0.01 for this. So this is 0.01.
Equals what?
No, he said.
Yeah.
0, 1 equals.
But you
For
can
that.
plug in 0.01 for DD, can't you?
And then you have 2 times
Oh, actually,
dd over
can you get it
d.
like that?
This is what you're
Is it trying to
finding.
find what?
This is your percent error for this side.
So divide that side.
Divide by 2.
The volume and
The volume.
0.01 over 2
confusing.
dd over d.
Yeah, that's your answer. So your answer would be, your error has to be 0.5, that'd be point,
0.05.
oh yeah, I didn't divide that, 0.00. So you're at 0.5% or less when you measure the diameter.
0.5.
That's pretty precise.
Yeah, so you better measure the diameter really closely or your volume's gonna be way off.
Which that's only common sense.
Yeah, because, well, that's not common sense.
To measure something accurately.
Oh, okay. I say, because, yeah.
Dang,
Wow, I have a
the
lot.
first day ever where we like actually go to where the bell. Oh
I
man.
have a lot of problems with it.
Can
no.
you not write them all, please?
And stop.
I'll take one off.